Hello students, today I am here with an interesting topic, solid state. Okay, so I know that all you are familiar with the term solids. I know because in your previous classes like in +1 you studied about solids in the chapter states of matter. Okay, so today I am here with discussing more points about solids. Okay. In this particular topic, I am going to discuss about these topics. That is, first of all, we are moving to the definition of solids, then next general properties of solid, then again classification of solids, that is they are classified into crystalline and amorphous, and finally classification of crystalline solid based on the nature of the bonds. These are all the topics we are going to discuss today. Okay. So, let me recollect your memories. That is, I told you in your +1 classes you studied about matter, isn't it? Yes. So, what is matter? So, how will you define matter? Matter is anything which occupies in space, that is which has got a definite mass, that is what we call matter. Matter is anything which occupies in space and that has got a definite mass, or we can say that any stuff and which the entire universe is made up of. By looking at the surroundings, we can see more things. Everything is matter because it needs some space to occupy and it has a definite mass. So, everything belongs to matter. Okay. And you know, matter is divided into different parts based on the physical states. So, matter is again divided into different types based on the physical states. Which are they? Commonly we are saying mainly 3 states of matter. We know that we have a 4th state of matter, that is what we call plasma state. Plasma state, this is the 4th state of matter. Okay. And in the entire universe, most of 99% of the substances belongs to this plasma state. Only 1% left, that is belongs to the other 3 states. Which are they, the other 3 states? This also you studied in your chapter states of matter. That is, the other 3 states are solid, first one, and second is liquids, third is gases. And among these, in this chapter we are talking about solids, that is what we call solid state. Okay. And liquids, about liquids and gases you are studied and you are going to study the upcoming portions, right. So, now we only concentrate on solids. Okay. So, now what is solid and what is the definition of solid? Okay. So, you can see this structure. In this structure, it consists of a different constituent particles. What are the speciality of this particle? On seeing itself, we can see that all the particles are very closely packed. All the particles are very closely packed. That means the force of attraction in between the particle is very strong. The force of attraction is very strong, that is why they are very closely arranged, and their energy will be minimum. So, you know, when you give any heat energy to a solid, it acquires thermal energy and its kinetic energy increases. Okay. Then the particles become mobile and it transforms to a liquid state. What I said? When you give some heat energy to a solid, what will happen? It acquires more kinetic energy and the particle will be mobile and it moves into the second state, liquids. Again we give some more heat energy, it will goes into the other state, that is gases. When you do the reverse of the process, what will happen? That is, when you cool, gases, it will return to the liquid state. When again cool it, it will come back to the solid state. Okay. So, now consider the solid state. What I told, the energy is minimum. When energy is increased, it will become liquid, and then further increase, it will become gases. So, in solid, you can say that solid is a substance in which the constituent particles. What is constituent particles? Maybe atoms, molecules or ions. So, in solids, the constituent particles such as atoms, molecules or ions are very closely packed with a minimum kinetic energy, and they are having a strong force of attraction between the molecules, between the molecules or ions. Such substances are called solids. Such substances are called solids. So, in solids I told you which possessing strong intermolecular forces of attraction. Suppose we consider the constituent particles are ions. Ions like positive and negative ions. Okay. So, I told you strong forces are there. Strong forces means positive, unlike charges have strong forces. So, I can write one positive, negative, positive, negative, positive, negative like that. These are the, consider these are the particles of solids. Then when you give any kinetic energy, what will happen? The bond will break. When you give any kinetic energy, what will happen? Here the bond will break. And where is the second bond? In between the negative and positive, and here also bond is there, bond is there, bond is there. And every bond is with the same strength, because this bond is in between positive and negative ions, this also between positive and negative ions. So, every bond is having the same strength. So, when you give any energy or thermal energy, suppose we are giving 115 degree temperature, heat, thermal energy, what will happen? This bond will break. Here also the same temperature we need, because the same type of bond is here also. So, all the bonds, for breaking all the bonds we need same amount of thermal energy. So, we can say that solids have sharp melting point. What is that? Solids have sharp melting point. Okay. Solids have sharp melting point. So, when you look at this, another example, that is when positive, positive, negative, negative, these are the charges. Here what will happen? Here what will happen? Here the bond between this, first is between two positive charges, and the second case in between positive and negative, then in between negative and negative. Here what will happen? First bond is very weak. We know that like charges do not attract that much. So, this bond will be very weak, and here in this case the bond will be strong. So, here we need about 115 degree of temperature, but here we need not have that much of temperature, because the bond is very weak. Suppose we need only 40 degree here. So, what will happen? The melting point will be different. So, we cannot say that here we have a sharp melting point. So, do not possess a sharp melting point in these type of solids. They are called amorphous solids. This is the second type of solid, amorphous solid. That is, we are coming to the classification. So, in solids I told you positive, negative ions are there. On seeing this structure itself, we can see that here after a positive, the negative is coming, positive, negative, like that. From seeing the last symbol, we can predict the first what is upcoming. So, that is the positive. So, when you closely watch this pattern, we can see that there is a regularity in this arrangement. Regularity in this arrangement. So, we can say that solids are regular in their arrangement. So, how will you define solid? They are very closely packed, minimum kinetic energy, regular arrangement are called solids. Such substances are called solids. I told you just now, when you heat or when you give any thermal energy to solid, what will happen? It come to its liquid form. When you give some heat energy, it will come to its liquid form. Liquid form. Okay. So when you cool this again, it will come to original, that is solid form. When you cool, it come back to its solid form. Okay. So in some other substances are there, when you cool them, they come back to solid form, but do not possess any regularity in the arrangement. Like suppose positive, positive, negative, also this in a random arrangement will be there. When you cool the liquid, it will be come back to the solid state. It seems like a solid, but actually it is not a perfect solid. That is, it do not possess the specialities or features of solid. Such substances are called supercooled liquids. Such substances are called supercooled liquids or amorphous solids. Such substances are called supercooled liquids or amorphous solid. Okay. So next is general properties of solids. What are the general properties? I told you solids possess a sharp melting point. Solid possess sharp melting point. Due to why? Because its closely packed arrangement, strong intermolecular or interionic force of attraction, minimum kinetic energy and regularity in this arrangement. That is why it possesses a sharp melting point. Then it possesses high density. Then next property of solid is low compressibility, and it possesses a definite shape, and this is rigid in nature. Rigid in nature. Next we will move on to the classification of solids on the basis of the nature of the particle present. Next is classification of solids. I told you based on the nature of the particle, solids are classified into two types. Which are they? That is crystalline solids and amorphous solids. What is crystalline solids and amorphous solids? And what is the major differences between these two? That is the differences between crystalline and amorphous solids. It's a very important question. So you have to thorough with these differences. Okay. So I told you in crystalline solids there is a regularity in its arrangement, that is positive negative ions are repeating. Okay, regularity in its arrangement. So first we can call in crystalline solid, we can say that in crystalline solid there is a long range order. Okay, we can say that there is a long range order because their internal arrangements are well defined. The internal arrangements are well defined. So we can say that crystalline solid possesses a long range order. But what will happen in amorphous solids? They do not have a long range order. That means they possess a short range order. They possess short range order because you know that their structure is not well defined, particles are not closely packed and do not possess a very unique or regular pattern. So this possesses a short range order. That is the first difference between the crystalline and amorphous solid. The next point is in crystalline solid we have sharp melting point. Why it is so? That I already told you. In crystalline solid we have same types of bonds here. So we need same amount of thermal energy to break those bonds. Okay, so crystalline solids have a sharp melting point. But what will happen in amorphous solids? Amorphous solid I told you in earlier I told you there is not the presence of same type of bond here. That means they need different types of thermal energy. So we can't say that it possesses a sharp melting point, that is it is do not have a sharp melting point. In amorphous solids do not have a sharp melting point. Okay. And then next point is it have a characteristic heat of fusion. In crystalline solid, it have a characteristic heat of fusion. But in amorphous solids, there is no characteristic heats of fusion. That is what I just told you. Here we need 115 degree means entire bond need 115 degree only, but here not so. So, there is no characteristic heats of fusion in the case of amorphous solids. That is the another difference. And next we going to go through these, that is the crystalline solid are regarded as true solids. What they call? True solid. But amorphous solids are called supercooled liquids, or we can say that they are pseudo solids. Pseudo solids. Why it is called pseudo solid? Because by seeing we can think that it is a true solid. By seeing itself we can think that it is a true solid. But when you heat them, what will happen? It converted into its liquid form. When you cool again, it again come back to its solid form. But they are not true solid. Such substances are called pseudo solid. Another important difference is, in crystalline solid there is a regular pattern we can see, right. This type of regular pattern we can see in crystalline solid. So, what about the physical properties? Suppose the properties towards light, what will happen when we pass through any light through the crystalline solid? What will happen? Same type of, so one single line passes, another in this direction when you pass through any light, it have a unique property. Another line possesses another property, then another property. So, the term we can call it as anisotropy. What is called? Anisotropy. And next difference is, that is, it is a special type of property, that is crystalline solids are anisotropic in nature and amorphous solids are isotropic in nature. And what is anisotropy? Yes, I told you in crystalline solid we can see that regular arrangement of units or constituent particles. So, in this particular structure we can see that the constituent particles are arranged in a regular fashion. So, when you pass through a light in this through these solids, what will happen? Every beam of light have different properties. By seeing itself we can see that every line having different properties. Such property is called anisotropy. That is different physical properties in all direction. What is anisotropy? Different physical properties in all directions. So, different physical properties in all directions. That is in the case of crystalline solid, because they are having regular fashion arrangement. So, they are anisotropic in nature, that is different physical properties are in all direction. But what about amorphous solids? They are isotropic in nature, What is isotropy? Same physical properties in all direction, that is what we call isotropic in nature. Okay. Next we can see some examples for crystalline solid. What is that? Crystalline solids, in the coming chapter, in the coming topics we can see most of example, because in the entire unit we are going to study about solids only. So, that is crystalline solids only. The amorphous solids we will stop here itself. In the upcoming unit, in the upcoming topics of this unit we are going to discuss about the crystalline solids. So, lots of examples you will see in the upcoming classes. Then now I can say some examples, that is NaCl, KCl, quartz, diamond, etc. are examples for crystalline solids. Then next amorphous solid. What are the examples? Glass, rubber, polymers, etc. Next is classification of crystalline solids on the basis of nature of bonds. Okay. So, what is meant by bond? Bond is defined as the attractive forces which binds the atoms or molecules together. That is what we call bond. On the basis of the nature of the bond, the crystalline solids are classified into different types. Based on these types of bond, the crystals are classified into different types. Which are they? So, first one is ionic solid or ionic crystals. So, we are now discussing about the classification of crystalline solid based on their nature of the bond. What is meant by bond? It is an attractive force that binds the molecules together. In crystal, we have different types of these bonds. On the basis of that bonds, the crystalline solids are classified into different types. The first one is ionic solid or ionic crystals. And what is the type of, what are the constituent particles present in ionic solids? Earlier I told you, that is the positive and negative ions, or we can say that cations and anions present in the ionic solid. The constituent particles are cations or anions or positive, negative ions. And the type of bond present in ionic solid is electrostatic forces. Electrostatic forces such as ionic bonds or Coulombic forces of attraction. Electrostatic forces such as ionic bonds or Coulombic force of attraction. Then we can say few examples for ionic solids. Which are they? As I told you, it consists of both positive and negative ions. So, we have tremendous of examples, so that is NaCl, ZnS, CF2, BaSO4, K2SO4 etc. are some of the examples of this type. Then next, physical nature. What is the nature of such substance solid, that is in ionic solid? What is their physical nature? Ionic solids are hard and brittle, and they have high melting point, and also they have high heats of fusion. That is the physical nature of ionic solid. Next, their electrical and thermal properties, and they are found to be poor electrical and thermal conductors. They are found to be poor electrical and thermal conductors. And the second type is what? Molecular solids or molecular crystals. In this type, again subdivided into three parts, which are the non-polar molecular solids, then polar molecular solid, then hydrogen bonded molecular solid. So, we consider the first one. What is that? Non-polar molecular solvent. Here also the constituent particles are nothing but the molecule itself. In non-polar molecular solvent, the constituent particles are molecules itself. And what is the type of bond present here? In molecular solvent, in non-polar molecular solid, that bond present here is weak van der Waals forces. Weak van der Waals forces or dispersion forces like London forces. These are the forces present here in this non-polar molecular solids. Then we can see some example for this, which are the F2, Cl2, Ar etc. are some examples for non-polar molecular solvent. And what about their physical nature? Their physical nature, we can see that they are soft, low melting point and low heat of fusion. Soft, low melting point, low heats of fusion. And what about the electrical and thermal property? They are called insulators. They are known as insulated. And the next classification is, among molecular solid we have the next classification, that is polar molecular solid. In polar molecular solid also we can see that the constituent particles are molecules itself, and the force of attraction in between them is dipole-dipole forces of attraction. Dipole-dipole forces of attraction. And we can see some example for this, that is HCl molecule SO2, HCl SO2 etc. are some examples of polar molecular solids. And also they possess the same physical nature as that of non-polar molecular solvent, that is they are soft, low melting point, low heats of fusion. So, next is the electrical and thermal property also same as that of non-polar molecular solvent, that is they are also simply insulators. The next classification is hydrogen bonded molecular solids, hydrogen bonded molecular solid. Here also the constituent particles are nothing but molecules, and as the name indicates, there exists the type of bonding is hydrogen bonding, which is the type hydrogen bonding. What is mean by hydrogen bond? When it forms a hydrogen bond. So, simply we can say when hydrogen atom attached with atoms like oxygen, nitrogen, fluorine, then there is a chance for the formation of hydrogen bonds, that also you studied in your earlier classes. So, when a hydrogen bond is formed, when an hydrogen atom attached with the atoms like oxygen, nitrogen or fluorine, there is a chance for the formation of a hydrogen bond. So, in hydrogen bonded molecular solid, there exists the force of attraction is hydrogen bonding itself. Okay. Now, we can see some examples for this type of solids, that is H2O, NH3 etc. Because here the presence of oxygen is there, so there is a chance for the formation of hydrogen bond, and in NH3 there is nitrogen is present, so there is another chance for formation of hydrogen bond. And what about their physical nature? Unlike other molecular solids, they are hard, they are hard in nature, but like other molecular solid, they are low melting point and low heats of fusion, and also their electrical and thermal properties same as that of other polar and non-polar, that is they are also insulators. And that is all about the second classification, that is molecular solids. Then third classification is covalent solids. In covalent solids, we can see that the constituent particles are atoms which are in a covalent network. So, you know how the covalent bond is formed. The covalent bond is formed by the sharing of electrons between the atoms. Okay. So, here atoms of covalent network is there in covalent solid. So, there is a chance for sharing to form a network of structure. So, in generally we can say that in covalent solid, molecules are in a the solids are in a large size or having high molecular mass due to their network structure. Okay. Then what is the type of bond present here? Here the nature of the bond is covalent bond itself. I told you what is covalent bond, that is the bond formed by the sharing of electrons. Okay. Then we can see some examples for such type of covalent solid, that is diamond, quartz, silica, etc. are examples for covalent solid. And what about their physical nature? Because they are having strong covalent bond, that is why their nature also very hard, very high melting point. Okay. So, they are very hard and very high melting point. And about their electrical and thermal properties, they are poor electrical conductors. They are called poor thermal and electrical conductors. Next we move on to the last type, that is metallic solids. Okay. And here the constituent particles present is cations in a sea of electrons, cations with a more number of electrons, that is the constituent particles present here. What about the nature of the bond? The bond will be metallic in nature. So, in metallic solids, the constituent particles are atoms with cations with the presence of electrons, and the bond will be metallic bond. Now, we can move to some examples, which are the copper, zinc, iron, etc. are the some examples for this metallic solid. And what about their physical nature? They have low melting point to hard melting point, or they are soft to hard nature. Okay. And what about them? They are all metals, isn't it? Copper, zinc, iron, these are all metals, that is why we can call it as metallic solids. So, you know the properties of metal. In your lower classes that also you studied. What is the properties? They are malleable and ductile. So, we can add that also in the physical property column. Okay. So, strong to hard, low to high melting point, malleable and ductile. These are the physical nature of the metallic solid. Next we move on to electrical and thermal property. We can say that they are excellent conductors of electricity. They are excellent conductors of electricity. Okay. So, in today's topic we discussed about solids and their properties and the classification of solids, that is crystalline solids and amorphous solids. Then again the classification of crystalline solid based on the nature of the bonds presence. So, next class we will discuss more about crystals and their unit cell. Okay, thank you.